Hello and welcome everyone. Thank you for joining us today for our webinar titled Key Terms and Ideas in Responsible AI. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers. Benjamin Fox is a product marketer at H2O.ai, and Patrick Hall advises us on responsible machine learning at H2O.ai. Before I hand it over to Ben and Patrick, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Without further ado, I'd like to hand it over to Ben.
Hey everybody, thank you for taking the time. This is part of sort of a series we've been doing on responsible AI. And some of this work is evolving. We've kind of tinkered around with this and are looking at new ways of displaying it and how we should kind of bucket the core themes that matter and we find really important. So that will give you some kind of context of what we're going to do. I think I have about 45 minutes to talk, and then we can do some questions, I believe. Responsible AI is a lot. Like, there's a lot of discussion around it in the industry, and there's a lot of ambiguity about what is something and what is not, and we're going to kind of get into that. So basically what we aim to do here is take this area and bring it to you as we see it, right? There's a lot of academics, a lot of researchers, a lot of tech companies are looking to kind of, just define what responsible AI means, and we're just here to tell you what it means to us. So with that, let's kind of just go through. This is important for a lot of reasons, right? Like,
Real quick. Yeah, just real quick. And we're here to start a discussion, not to finish a discussion, right? This is early days for what people are calling responsible machine learning or responsible AI. So these definitions that we're going to throw out they're good. We like them, but they're proposals, right? And we need feedback on them, and we need the community to engage not only with us but with each other to figure this stuff out.
Yeah, and that's a really good point. Everything we push here for today, or for you guys here today, we are really open to this discussion. That's not a platitude. This is something that we take really close to heart. I think, if you go to LinkedIn and follow any of us, you can see us engaging in these kinds of conversations, proposing ideas. What's really, exciting about the data science AI community is that, our motto at H2O is democratize AI, but machine learning and data science has been very democratic from the get-go. All of these, latest and greatest models are always made public. XGBoost, all of these libraries kind of go public, and it's really, really good for the innovation curve and adoption cycle. It really helps push the field forward when you have companies, businesses like Agile sharing code and showing new ways of doing visualizations or models. It's really helpful to push this area forward, and that's what we've seen in the last few years, and I think it's really exciting. So I'll start off with a quote. I think a lot of the discussion around AI is very grandiose and very speculative and salacious. I think it's important because of how technology works that we get it right. I don't foresee any kind of situations on our horizon like some of the more doomsday preppers, but I will say when you get into the prediction business of using historical data to predict the future, there's a new tranche of considerations that you have to take to heart. And, it's different from typical software development. We're making predictions that affect people's lives or your company's life. So it's important that we get it right, and it's important that we take this quote to heart and really think about the risks in the space. I like to start with this side too, because I think many people on the call have probably heard at least one or several of these. These fail cases are tough, right? They take trust away from this industry. They cause a lot of speculation. They appeal to not too many great things. But the problem here is it's not necessarily an AI failure. A lot of these are actually, data failures and historical data that actually ultimately drives these pretty statistically sound predictions actually give life to something in your data that has a more concerning piece at play. Like if you have a loan book and you're trying to decide who's getting a loan, and you use 50 years of historical data and you're trying to predict who should and should not, and you find out that your model is discriminating, it might not be the model. It might be historical lending practices that have not always been fair. So that's really important to consider. And then I kind of want to just put this out here. There's a lot of different bullet points. I don't necessarily want to dive into each one. I think that'll take too much time. But it's important to notice that there is this is just a one-year timeline of how many things went wrong and actually damaged the public trust in AI, data, and analytics. And it's just something that we're fighting against. This is a very emergent technology, but there's a lot of public cases that we're working against, and that's where responsibility comes in. Go ahead.
Just really quickly, I find this fascinating, right? Like in cybersecurity, we talk about incident response. I'm pretty sure in AI we're going to be talking about incident response very soon. And in fact, Partnership on AI seeded a database with about 1,000 publicly known AI incidents in it. There's another interesting GitHub called Awful AI that also tracks these things. So, you know, AI, I think it's a technology that's sort of akin to commercial aviation or nuclear power. Very powerful, very important, very useful. But you know, even with tight regulation, we can still expect incidents. And right now, there's very little regulation, and operators are left to kind of come up with their own model governance. And you know, in these conditions, I think we'll see a lot more of this. And I wanted to point out the Partnership on AI incident database, which I think is interesting. And I'll shut up and hand it back over to Ben.
Yeah, so first of all, the partnership database is an awesome exercise. I really think there's a ton of value in that, and it's really good as practitioners we're aware of kind of some of the fail cases, so we can be cognizant of what traps to not fall into. One way to think about this and why it's so critical to get it right is you can Google like algorithmic or high frequency trading and like algorithm gone wrong, and you can see a couple use cases that I kind of lived through where a model went wrong at a trading firm that was doing hundreds of million trades a day, and instantly a company can get bankrupted, or instantly everything can go wrong. When you get into this systematic, prediction business, especially at a rapid clip, the rate at which things can go wrong is very fast. So as data science practitioners, not just for the health of your company or for the health of your customers, but we just need, it's really systemic risk. Like, we should all feel responsible. Go ahead.
Just to piggyback off that, and sorry, Ben and I are not, obviously, it being April 2020, Ben and I are not in the same room, so it's for us not to interrupt each other. But just kind of piggybacking off that comment, that is why AI is such an important part of digital transformation. It accelerates decision making, right? So a machine learning model can make, I don't know, hundreds of thousands, millions of decisions an hour. And if those decisions are wrong, and you don't know about it and you're not prepared for that, then watch out. Like you just made 200,000 potentially harmful decisions in 1 hour or more. And there's a article in Science about a healthcare scoring system that one of the major insurers used. And I'm quoting Science here. I'm talking about the Science article. I'm not talking about the insurer. They think they scored. They think that 200 million people a year could have been scored by similar systems, and the system was found by researchers published in Science, to have some kind of racial discrimination aspect to it. So, and they're thinking 200 million people per year. So the scale, we use machine learning as a central part of digital transformation because of the scale, right? And so it's very powerful, like an airliner, like a nuclear reactor, and we have to be careful with it.
Yeah, it's actually funny you mentioned that example, because my AI class professor at graduate school just released a paper in the fall about healthcare discrimination via the models that they had in place. And now, my college actually has an AI Center for Applied Research that's going out to the hospitals and these healthcare providers and trying to kind of get under the hood and find out what went wrong or did something go wrong in your specific unit. And this isn't very material, right? Like, I think for a lot of people, it's not really it's not very real to them if it's finance, if it's just kind of money, you know, non-physical product, moving numbers from one page to another. But when you talk about healthcare, manufacturing, it really starts to hit home at like how much can go wrong. So what I'm here today,
and just, I guess real quick, sorry. So, and I think Ben is in agreement with this, right? Like these problems, when they happen, they are very personal, right? And they can seriously affect people's lives. And I think what we want to talk about today from H2O's perspective is risk, right? That there's just a risk that all, you know, kind of commercial technologies have had for it, right? They have pros and they have cons, they have opportunities and they have risks. And I personally find it most sort of constructive, especially in the business context, to think about these terms, to think about these things in terms of risk mitigation, right? We want to adopt machine learning with minimal risk.
Yeah, and I'll kind of segue with that. I think I come from the same frame of mind as Patrick. I came from a finance background, and all of this, you know, about algorithmic implementation or intelligent automation was really, you know, it started in mitigating risk. Like humans make mistakes, so let's have an algorithm do it because it'll make less mistakes. But by having algorithms automate decisions or knowledge, you have to then make sure that your model is not making risky decisions, or how can you mitigate those decisions? So really what we did at H2O, because some of our biggest stakeholders, customers, partners, and clients are financial services firms, we were one of the first, you know, we were very on the bleeding edge for explainable AI. That started a few years back, and it's really a conversation about, you know, well, I'll get into the definitions, but this is where we started, and you'll see kind of how it rolled up this bigger picture of responsibility, right? I think explainability started as tools to statistically audit machine learning and AI, right? In finance, you know, for lending decisions, you had to be able to audit these models or kind of unpack these models and see what the root cause of that decision was. It's harder with machine learning. It's harder with nonlinear models. It's, you know, we've been slowly progressing forward in figuring out what are the latest and greatest technical methodologies to actually kind of review and analyze these models after they've made a decision. But what that then drives is a large question, right? The larger question is, okay, say you can analyze a model, that's all fine and well, but really it's how does your company get built around AI and machine learning? You have the people, process, and technology in place to consistently create models that are stable and sound, and that explainability can really matter. Because if you don't have the organizational, you know, the people component, the process component, the technology component, none of explainability matters. If you're feeding terrible data into a model, explain that model is not really going to matter. Right? So it's about thinking about the larger picture as you're a company scaling into big investments or, you know, smaller tactical investments to try out the AI ML space to see if it's a fit for your business. So it's about a bigger umbrella, right? And the way that we kind of look at this is kind of sixfold. The subjects you see here, or the circles you see here, really are all part of a responsible AI like benchmark or best practices or framework for your company, right? It's not a little bit of this, it's a little bit. Go ahead.
From a technical perspective, right? Like Ben and I have done this webinar a couple times recently, and we were on with someone very brilliant yesterday from a partnership on AI, and they were talking about like people problems in the AI supply chain and you know, silos in corporations, and all of those things are very, very real. We're not trying to downplay that at all. We're just a technology company, so we're going to focus on technical solutions, but there are immense people and process issues here too. So just that little preface.
Yeah, so let me piggyback off of that, right? I started to tee this up. This came to us via technology, right? We started in the explainable AI space. We've been a leader in the space. And we're not going to spend too much time talking about the tools at play, but understand that when we create an auto ML platform, we want a auto MLI platform or an MLI platform that can sit on top of that and give you all of these core metrics that you need to really understand your models. Like I think explainable AI, we started with concepts like feature importance. We started with concepts like sensitivity. We moved to things like disparate impact. There's a lot of technical ways you can unpack models, right? It's really, really critical because something that happened in industry, I'm not sure of the audience demographic, but AI, the math has always existed. We've always kind of had this math since maybe the 50s, and really we've seen this monster resurgence because of technology advancements, digitization of companies, computing power got phenomenally cheaper, faster. Data became phenomenally more available. The curve of data creation in the last decade is beyond parabolic, right? So, we have these learning models that are learning over time, learning with new data, adapting, changing based on certain predictions, and are really kind of living, breathing things compared to old school statistical analysis. So, I remember 3 years ago or 4 years ago, when we were starting to really deploy machine learning solutions to our customers, they had these questions about explainability and auditability and how do we know what's going on. And part of the problem is deep learning took off and became this silver bullet. Every company wanted to use deep learning. Every company that was using deep learning was getting funding. Every paper with deep learning was getting published. But the problem is that architecture conceptually of deep neural networks with hundreds of hidden layers and nodes and epochs is very, very hard to explain. And we put out a paper recently that proposes a new explainable neural network that for tabular data is completely explainable, or as explainable as you get, right? And I think what's really cool about this space is it started off as a couple skeptics and people just appropriately concerned about risk, has really become center stage, right? Everybody raced into explainability. Now everybody's racing into responsibility. And that's why we're kind of proposing this framework, because we want to help push the conversation forward, right? Like I think, there are books about this. There are all sorts of new papers. I think all of the big technology firms have differing ideas in some area or another. But this is how we've kind of looked at it, and this is what makes sense to us right now. But as you mentioned earlier, and we're going to keep saying, is please reach out. If you have ideas, if you have want to debate or support, please reach out. Like we're still workshopping this. We're really just trying to drive the dialogue forward because at H2O that's kind of what we do, and as data scientists, that's what we should be doing, right? So the next thing that we kind of look at is interpretable machine learning, right? This trade-off between explainable AI and interpretable ML, this one is a little more vague, but the way that we see interpretable machine learning is about model architecture, right? I just talked about how unclear neural networks can be in unpacking and explaining and doing post-hoc analysis, but a rules-based decision tree is quite easy. That's one of those if-then statements that a lot of people classify as AI, appropriately so, but it's very, very explainable and it's very, very intuitive. And if you range from expert rule systems or rule-based systems to neural networks, there's so many things in between. Random forest, support vector matrices, XGBoost, ensemble. Go ahead.
So maybe a little bit of clarity here is that explanation in machine learning, for the most part, when people talk about this, they tend to mean things that we do to a machine learning model after it was trained to kind of summarize information that the model learns. So the key with explainable machine learning is it happens after the model is trained. And then with interpretable machine learning, like Ben said, we're talking about model architectures. And as Ben was hinting at, there have been many, many developments in interpretable models over the past few years. And just throwing some names out there, GA2M by Rich Caruana at Cornell, which is kind of morphed into explainable boosting machine at Microsoft Research. Cynthia Rudin at Duke and Harvard has been doing work on this, for years, and highly regarded work in the academic community, but less well known in the practicing community. And so this idea of interpretable, accurate models is coming to the fore, and that's what we mean when we say interpretable machine learning. Machine learning models that where the algorithm was designed to be interpretable. All right, I'm going to shut up.
No, you just made me realize how much time we must have spent in this space so we can name off, the various model developers, originators, or like pioneers by name and what model they built. So I guess let me click forward, right? I think this one is going to be really top of mind for a lot of people. When we talk about responsible AI, I think we made this point yesterday. We came to responsible AI via explainability and via the technical tools that we can use post hoc to audit a model. A lot of people reached responsible AI via the ethical component, which is often fairness, right? Is one ethnicity being treated unfairly in a loan decisioning process by a model than another? This is a classic case that I think a lot of people are concerned about and find, are the most upset when they find out occurred. Or various gender biases in hiring and resume review and these kinds of things. Now, I want to just make a big caveat here, right? We use the word ethical AI. We very much at H2O try to avoid saying, what is ethical and what is not. I mean, there's a great YouTube conversation about 21 definitions of ethical or ethics or fairness. And it's really, this is hard, right? Ethics and fairness are its own science, right? And we do not come from that background. We do try to make tools that give you the ability to click down in program in your model and determine if one category of a person is being treated differently from another, right? And why. That's the core of what this is to us from a technical perspective. But as we mentioned, our conversation with partnership on AI yesterday, they can bring to light a whole different host of issues, from where was this data generated? Was the data created in a place with a responsible business practice? From very, it might be innocuous to a lot of folks, but, not all data is created by sales systems, right, or booking systems. Some data that's created to train models is, mechanically turned, right? And that creates a whole slew of considerations that we really haven't touched, but we really take it from a, disparate impact of one category of a variable versus another, and making sure, you can be able to poke around under the hood and make sure that's not going on. And if so, how do you kind of combat it? And the next category, I might lean on you a little, Patrick, here, but the top line of this is that AI models are not classic software, right? It's, software and websites can get hacked. We've seen all the cybersecurity risks, but people seem to gloss over this idea, models are hackable. Models can be poisoned. And there's a whole tranche of things that I think Patrick's written a ton on that really doesn't get nearly enough of the conversation that it deserves. Patrick, do you want to chime in at all?
Yeah, that's because nobody cares about security, and no one cares about their data, not even you, and not even me, honestly. Right? It's cybersecurity just gets worse and worse and worse, and harder and harder and harder to dot every I and cross every T. And a call before this, completely sort of hearsay, but I live in Washington, D.C., and was doing a call with some people in D.C. right before this, and one of the person's spouses works at one of the three-letter agencies dealing specifically with cybersecurity, and one of their happy hours was Zoom bombed by hackers, right? And so, that's what I was saying when I was saying no one cares about cybersecurity, even you. It's just too hard to keep up with, and so machine learning is a new target. It's a new attack surface. There are published attacks against machine learning models that can be extremely damaging. We're talking about things anywhere from sort of a poisoning attack, like Ben mentioned, where I change the training data to get some kind of outcome that I want, to things to attacks known as a model extraction attack is particularly damaging because I can get a copy of your model just by interacting with your prediction endpoint. And once I have a copy of your model, I understand your proprietary business logic, but I also understand a lot about your training data. And probably the scariest attack that's been published is known, in my opinion anyway, is known as membership inference. And that's when we can tell if a row of data set was used in training data of the model. And if I can tell if a row of data set is used in the training data, I can eventually just build the training data. And so we're talking about altered outputs of models, so altering your business decisions. We're talking about stealing your proprietary business logic, and we're talking about stealing your sensitive training data. And no one knows how often these are happening yet. It's not something that will say, yay, my machine learning was attacked. But yeah, this is serious. I don't know how real it is yet. It's likely to be more and more real in the future, I guess, is what I'm comfortable saying. So I'll shut up and let Ben take back over.
Yeah, and the last point I'll make on this one, because man knows so much more about this one subset than me, is that, secure AI is in the, think about it in the cyber or, IT operations bucket, where at companies, they don't care until something went wrong, and then they're really angry, right? It's really thankless business because, they're keeping the infrastructure of everything sound, and they're fighting off like potential, firm-ending situations, but nobody cares until something breaks, right? And it just doesn't get nearly enough eyes on it or credit for that reason, right? So human-centered ML, this is a great area. It's actually getting a lot of topics. I think Stanford has their human AI center, and a lot of other places are thinking about the human and algorithm relationship, right? For us, this is just user interactions with AI and ML systems. Like, I think one of the biggest problems in the industry is, as a consultant, I would go out to companies and I would talk to them, and companies typically have two responses. One was, AI will never matter to my company, we don't need this. And the other was, okay, how fully automated can I go and how many people can I fire, right? And that second one is a particularly dangerous idea, because we talked earlier about the compounding damage that, a fast-moving, high-clip decision-making model can make. So building your AI and ML system around this idea of human centricity and being able to have a human in the loop at all stages, or be able to interact with the model, whether it's on the decision side or the appeal side, is really important, right? I think, we as like an elite data science team at H2O, we tried to design driverless and our platforms with the ability to do whatever you want within that model and tinker around with it and be able to see what's happening live, versus just, hundreds of thousands of automated decisions with not a lot of clarity of when things happened and why. All companies that are deploying AI and ML should look to create infrastructures that really have humans in the loop as much as is possible. And as Patrick and I kind of talked about, our belief system is that there will need to be more humans in the process, and at multiple different layers going forward. Like, we have a ton of research that we've done on the trends in regulation of this space. I think this will be something that's very aggressively looked at in the future. No, for me, it's not an if, it's a when. But obviously, that's just a subjective opinion. But I think as companies look to engage with AI and start to build into AI, this is something that they should really, really consider, because if you look at financial regulation and how much, there's various policies on this, but the idea is that when you're making decisions in finance that relate to your customer, whether it's loans, mortgages, this kinds of thing, you have to do a very aggressive amount of review and documentation on who touched what and when, what is the supply chain of that data being created to an ultimate decision point. It's called data lineage, there's a lot of different terms, but if you're going into machine learning AI business, this is something you should consider very, very sincerely, because you want to be able to know what your data science supply chain looks like, and everything from data creation to model deployment, decision making, and production should be of interest to you in seeing where things might break and why. This is a really popular slide. I think one of the things that gets overlooked a lot is the idea of what the undertaking of AI and ML really entails, right? We just gave you that big framework. Oh, there's actually one more thing I'll discuss here: compliance. I don't need to provide a definition of what being in compliance means. Anyone in finance is very, this is a very top of mind issue for them constantly. We believe that one of these core facets for responsible AI is understanding your compliance risk, being in compliance, and then preparing for compliance as it comes. You'll notice that highly regulated industries, whether it's finance, aerospace, nuclear, as they know regulation is coming to them, whether it's, whatever the regulation is, as soon as it's announced that it's going to go into place at a later date, they immediately start acting on their response plan and how they cut over for day one of that regulation or compliance policy being in effect. Firms deploying AI and ML should be thinking the same thing. We have a lot of thoughts on various regulatory policies across the world, and which might be better than others, which might be more self-aware than others. We're looking to put something out about that relatively soon. But if you are a company deploying AI and machine learning, you should go into this endeavor with a belief that compliance will probably become a very harsh reality of your life down the road, and you kind of dramatically reduce that pain point by taking on best practices now in this kind of six idea bucket here. Because if you do these things, if you look at these things, you'll be in significantly better shape from a more regulated, higher oversight future for AI ML. You can take it.
I know Ben has already said this, but I think that the further regulation of machine learning and AI technologies is just inevitable. Now, whether it happens next year or 10 years or 20 years is the question. But we can't even keep up with the amount of guidelines and actual laws that are being proposed in the United States and all over the world. So, and one way I like to make this real is that late last year, early this year, the Dutch government, for the first time, shut down a machine learning system because of privacy concerns. So, here we have late 2019, early 2020 as the first known public time that a government shut down a machine learning system. And I don't think that will be the first time. So yes, we can talk about compliance stuff a little bit later if people have questions. And just another quick aside, we see the questions coming in from the audience, and we sincerely appreciate them, and we'll address them at the end of the slides. So thanks for that.
Awesome. Yeah, and I'll kind of move quickly through the back half because this is what you guys came here to see. I think one reason to understand why this is important, and I'll give you a case that I saw in the workforce. Okay, so there was a period of time where lending was discriminatory, right? And fair lending policies came to the conclusion you should not use ethnicity as a variable when you predict somebody's default risk, right? That seems unfair. That seems like it shouldn't matter. So a lot of banks immediately took ethnicity out of their data set or their training data. But the problem is that variable they carried some signal because of previous historical human discriminatory practice. Like it had this leftover bad ethical signal that stood around in the data. So when you strip this variable out, a lot of these ML models are smart enough to reverse engineer or feature engineer a replacement for that. A hyper targeted zip code plus a couple of other variables can kind of recreate that based on demographic trends of a city, for instance, right? I'm not implying that these models go rogue, but what I should imply is that you should be very cognizant of how smart some of these models can be and how certain aspects can be recreated or permutated or imitated. And it's just a reason to keep another very stringent review of when your models are making decisions and why. I think I talked about a lot of this in the last slide, but a lot of times if you're a company, the two things, this is three things you're thinking about are we don't have data scientists, we don't have the people who know how to do this, how do we get started? And then the other side is well, what if it goes bad and, it goes public and it's terrible for a brand, and then we're highly regulated because we were a bad actor because of our model? Those are really the top of mind issues, but what's really critical for firms to understand is all of the other components of this, right? Like we talked about ethics and bias, we talked about cybersecurity. I think the ones that I haven't touched on are like technical debt, right? I think people underestimate how much should go into refreshing models, reviewing models, updating your data, watching for data drift. Risk management, that's something we talked about earlier. There's risk management of, automated algorithms, that are making decisions at a pretty fast rate is pretty critical, right? Like you have to know when you're acting out of, your typical standard, volatility parameters, right? Like you need to know this. And then back to the people, process, technology component, automation concerns are a very real organizational change management issue for companies, right? You're going to automate an entire team of, KYC, EDD employees who are like checking, potential onboards for, political exposure or history of criminal behavior, and you're going to go audit that job with an algorithm. What do you then do with those teams? A lot of times people just think, oh, well, we just let them go. That's not really the right situation. It's about finding a nice balance between keeping certain people in place to oversee a new augmented world where they can, use these algorithms to make their job easier or more accurate or, more efficient, while taking some of the other folks and putting them in profit-driving exercises and keeping their institutional knowledge. It's not just a, cost-cutting, letting people go exercise. There's really an augmentation component to this, super valuable. But you need to have that conversation. You really need to consider what that looks like. This is one of my last two slides, right? And then we'll open it up to questions. One of the problems we find a lot is business leaders and data scientists think they have conflicting views, right? Business leaders and, executives are all focused about risk, right? They want to know how much risk they're taking on. They want to know how much risk they're reducing with these models. That's their core focus, right? They want to monitor risk. Data scientists spend their time focusing on trust, accuracy, but also trust, right? And you think that, by increasing trust, these might be things that a lever that you have to pull in one direction or the other. These things are actually cyclical, right? It's a snowball effect. The more risk you take off, the more you can trust your model. The more you trust your model, the more you understand and can mitigate risk, right? It's just that simple. These are two drivers and focus points that matter the most to companies that we engage with, and they're actually the same goal, right? You see people who think you're like cross-cutting in terms of what you want. It's the same thing, and one helps the other. So it's this kind of positive feedback loop that companies should be aiming for with their AI deployment. This is the last slide, right? And I think I'll open it up afterwards. I'll caveat this with, we have a significantly more robust version of this with many different flows. But in the interest of, talking to an executive level here or a business user level here, I just want to leave it at this, right? All I want to propose here is your typical model development lifecycle is the 3 in yellow, right? It's data loading, prep, EDA, feature engineering, train and review the model, and then deploy the model, and maybe review it, hopefully review it. But what we'd like to propose is, this green bubble here, right? It's about explainability, interpretability, fairness, data security here, compliance. It's all of the responsible AI bucket we've talked about. You should have this at a very aggressive feedback loop, and if you're failing certain levels, like, one category is being treated unfairly, immediately go back to training and assessment and tinkering with your model to get it right. This iteration cycle should be quick, and it should be swift, and it should be often. That being said, I think the point I want to make is, if you look at the top with the red arrows, a lot of times people think bias can only be introduced into a model in the data set, or maybe in the review of what the model did, and taking a bias into that level and then maybe making a decision based off that. Bias and data statistical errors can occur at any level in this process, right? It's critical to understand that bias, poor data, inaccurate data, and opinion can really bleed into this at any level. So it's critical to pay attention. I guess I don't know if Patrick, you want to jump in here at all, but I was going to just kind of wrap it up here and open it up to questions because I think there might be a decent demand for that.
No, I'm okay. I'll just say that we just did a paper called a Responsible Machine Learning Workflow, like Ben hinted at, where we have a much more sort of detailed version of this kind of workflow. And we can send that link out, or you can contact us if you're interested, or you can just Google it. It's a Responsible Machine Learning Workflow. But yeah, with that, let's close. Okay, great. Well, thank you, Ben and Patrick. We have some great questions in the chat window. We'll try to get to all of them with time permitting. First question is, how do we know which AI to trust when we see COVID models as far apart as they seem to be today? I have an opinion on this, and you should trust the ones that have medical professionals involved with them. Okay, and here's why I'm saying so. A tenet of if you get the textbook about responsible AI, and I said Ben and I were going to focus on the technology, but a very serious tenet of responsible AI is to bring domain expertise to bear on a machine learning problem. And I don't know if any of you have played with the Kaggle COVID data, but I started playing with it. And what I learned immediately is I simply couldn't tell if my results were good or bad. I mean, I couldn't tell if I had a perfect model or the worst model in the world. And that's because I didn't understand the data. I had I'm not a medical professional. My specialization is in machine learning, and that simply does not qualify me to be an epidemiological modeler. It might qualify me to be on a broader team that include epidemiologists and medical professionals and policy experts and statisticians. But just being good at machine learning, if I'm even good at machine learning, just point blank doesn't qualify you to build models about a high stake scenario like COVID. So I would take for my money, I trust the ones where medical professionals are involved.
Yeah, I'll add two quick caveats to that. One, the problem is when data science really kicked off, I think there was one really appealing idea that having data scientists who weren't too close to the subject modeling on things made them really unbiased and really good statisticians on the exercise. I don't think that's a good practice. I really do believe in this tenet. You should have domain expertise as much as possible.
That's Kaggle.
That really helps. Yeah, that really helps you understand what you're dealing with. Because to be honest, features, variables, if you talk about these historical pandemic models, they're not something that we as typical data scientists are familiar with. It's just people have spent years and years in that profession figuring out why those models look the way they do and what it all means. So that's one point. The second point I want to make too is you should always be wary of trusting models that are too grandiose or appear too good to be true or too accurate. I'm always wary when a company tells me they've created this dramatic deep neural network that solves this crisis, right? And it always leads me to not trust it, because if the scope of a model or prediction set is too big, I think you're just playing an overfitting exercise, really wouldn't be stable or sound in prod or out of sample. So that's just an opinion. I don't know if that's true, but I really do think you should just be wary of people selling snake oil if something sounds wildly too good or too accurate for somebody who knows nothing about the field.
Great, thank you.
We're getting some really good questions.
Patrick,
Yeah.
Which one? So the one about regret avoidance, that one seems really interesting to me. We need to answer the one about about which platforms can they use to model combustion. And I definitely want to address the explainable versus interpretable question. Now, that's a very good question. So there's a question about what H2O technologies can be used to do modeling in car engines or combustible, internal combustion engines. And so I think, both the open source H2O, which you can download and use forever for free, or H2O driverless AI, which is a more automated platform, which you can evaluate for free, but it's a commercial platform, so it's not free. Either one would be interesting to try for the use case about the internal combustion engine. So I think either one of the primary H2O products is the answer to that question.
I'll make one caveat there too. One of the things that we've designed within the firm is this idea of a mojo, which is like a leave behind model artifact, which can plug and play in like pretty much any environment, which makes it really easy for us to plug into kind of IoT situations like ATMs or factory maintenance machines, those kinds of things. So that would be how you kind of do that. I'm not a car expert. I don't know how an engine works, so I don't know how I would look to model that. Just clear.
Okay, in order, I think the one about the semantics between explainable and interpretable was first. So maybe I'll key off on that one. This is just my opinion, okay? And from sort of sitting in endless conference workshops and talking to people for years about this, there's no like fundamental science behind what I'm about to say. It's just how people in the field talk about it. So if you find it confusing, right, there's no fundamental justification. This is just my opinion on how people talk about these things in the field. So in the field, when people say explainable AI, they tend to mean techniques and processes that we apply to a model after it's been trained to summarize how it works, okay? And explainable AI has experienced some criticism, and the fundamental reason there is cause that, whenever I make an explanation, I'm basically summarizing, and summarizing always implies loss of fidelity. And so, understanding that loss of fidelity is very, very tricky. Like how accurate is my summarization of this very complex thing that I'm explaining to you? So, that's a little side comment, but explainable AI tends to be things that happen after the model is trained. There's no scientific reason for that. It's just how people talk about it. Interpretable tends to be applied to models themselves. So post hoc is after the model is trained. Interpretable is how people talk about machine learning architectures that have been designed from the ground up to be interpretable. And over the past 5 years or so, and going back even longer than that, but say like really in the last 5 years, a lot of these interpretable machine learning models have come along, and leading scholars in machine learning are making claims that these interpretable models are just as accurate, if not more accurate, than sort of the more traditional machine learning black boxes. So again, there's no scientific basis here, and maybe that's why it's confusing. In my experience, when people say, go ahead.
Oh, I was sorry. I thought you were at the end. I was just gonna say, like, one of my favorite data scientists has this like saying of beware of unnecessary complexity. That's a lot of what this is, right? Is us trying to get onto the edge of accuracy without sacrificing understanding how things work. And for what it's worth, in 5 years, these terms could be completely flipped. But from a business and research, just kind of like opining perspective, this is just where we're kind of at in terms of a loose definition of something. Because it's, we're talking about math, and it's just at a certain point you have to append a name to it as you see it. And the industry is still working through, so it might change. This is where we think everything is at.
And there's a comment or question about regret avoidance. The comment reads, I can't help but feel that institutional regret avoidance is closely associated with the core displayed in most of the responsible AI decks shared today. My biggest regret in 30 years of corporate experience were all associated with insufficient review. Keep emphasizing cross-disciplinary review in your future webinars. So, seems like a point from a experienced professional there. And so I think
maybe risk mitigation is just a nicer way to say regret avoidance. You know, I think a fundamental tenet here is if you use machine learning in a cavalier way, you could experience some very serious regrets. And, you know, this person is saying human review is incredibly important, and we fundamentally agree with that to the point where we've put significant effort in automatically documenting all of our models. So like when I train a model with H2O driverless AI, I get a giant Word document that a human can review automatically for every model. So you know, very quickly, human review is still incredibly important. What's also incredibly important is human appeal and override capabilities. Okay, so let's say, you know, 1,000 decisions in, 5 minutes into you know, doing your machine learning having some problem on you know, a highly scaled decision-making process, you notice there's a problem. Okay, if you build in override capabilities, then you can just override that system. But if you haven't documented, like, how much does it cost the business to turn this model off, if you haven't documented who to call when something goes wrong, all of that human override becomes a lot harder, right? And I'm kind of making documentation and review the same thing here, but that's another reason to do review, because if you see a problem and you don't know what turning off the system is going to do, then what are you going to do? You're going to be stuck. And then the other point here is human appeal of machine learning decisions, right? It's just one more step in your development to make your decisions appealable by the decision subjects. And this is actually one of the fundamental thoughts behind credit reporting regulations, right? They show you what goes into your credit score so you can say, hey, actually, I closed that credit card 5 years ago, right? And it's not easy to appeal. It should be easier, but at least it's technically appealable. So if you're making critical machine learning decisions, you probably need to give people the ability to appeal them. And that, again, is kind of a human review aspect that can happen automatically. Your users can tell you you're making a bunch of wrong, crazy decisions here. And so, yes, human review, human appeal, human override, really important. Ben, I don't know if you want to chime in. There's some technical questions below that I'd like to get to, but please go ahead.
Yeah, just a quick point for the review piece. If that's of interest to you, PDPC of Singapore, I believe it was, proposed a regulatory framework for AI where it literally talked about having a human in the cycle from data generation to, you know, just model monitoring in production. And there's very many layers of human cross-disciplinary review. So I highly recommend looking at that one. It's awesome.
So there's a few technical questions that we always appreciate. Aren't H2O model ensembles inherently less explainable than simpler models? Yes. The answer to that is yes. In general, now there's some caveats. We build in things like monotonicity constraints. Okay, and this is something that personally I'm a big fan of. So yes, an ensemble of 100 decision trees is a lot harder to explain than an ensemble, just a single decision tree. But the ensemble might have stability, which is another kind of crucial aspect of responsible machine learning. The ensemble might have stability benefits, okay? So if I can get the stability benefits of the ensemble and then use something like monotonicity constraints, so I can say as someone is later and later and later on their most recent payment, their probability of default has to increase in this model, and I apply those sort of same domain constraints to every feature in my model, I would argue that I can build a pretty interpretable ensemble model. So one of my favorite kinds of models is a gradient boosting machine with monotonicity constraints, because you get the stability benefits and you can inject some interpretability back into the model's architecture with monotonicity constraints. And then a subsequent question asks, what is your opinion about standard model interpretability such as variable importance, gap values? Is there global acceptance in using them as model interpretabilities? Very good question, and I'll be brief. So if I go back to my example with my monotonic gradient boosting machine, I can also use Shapley values to explain any given decision. So summarize any given decision. So now I have a stable ensemble model that's monotonically constrained with my own business domain expertise, and then I can use Shapley values to explain any one given decision, right? And then now we've combined interpretable models and post hoc explanation, and now we have something really special. There is not a there's no universal right answer for how to explain models. People have pretty wide opinions about this. I do think that Shapley values are something that at least in financial services, at least for structured data, at least for tree-based models, the Shapley values are really starting to gain some momentum and perhaps become somewhat of a standard. And if this term Shapley value isn't making sense to you, I suggest you Google it. It's really important. But we think we really like Shapley values. We also use Lime. We use variable importance. We use models of models, which is sometimes known as surrogate models. There's a whole grab bag of explainable AI tools, and I think the key is to use them together and pick ones that work best for your domain. And I better shut up.
The reality of it is just. So sorry, just to piggyback off of that.
No.
The reality of it is there's no perfect science for data science. Like making decisions algorithmic sounds like a little bullet, but again, like when you get into this space, it's just about pulling various levers, poking certain things under the hood, and seeing what's going on, and making an educated decision. That's why like data scientists aren't pure statisticians, right? Like we've got to do some like post hoc tinkering and stuff like that.
All right. Do we have time for one more, or are we done, Patrick?
Yeah, we can do one more if you guys.
All right, I'll do this one about the weaponization of AI, if that's okay.
Sure. All you won't touch it.
All right. Well, no, AI is going. If AI is not already being used for weapons, I'll be shocked. If it's not already being used for weapons, it will be used for weapons. So this is why we need to take responsible AI so seriously. And the regulation of AI seriously. AI will be a weapon of war. Do you want the AI that's used as a weapon of war to be made by a group of 25-year-old guys who's been in the basement of an NSA building for 6 weeks and hasn't talked to a single social scientist or ethicist or just other living human for 6 weeks? I mean, so. I really appreciate that question. Whoever asked it about the weaponization of AI. That's coming. There's nothing we can do about it. I'm pretty sure it's already here, and that is a reason why you want the people making these technologies to be thoughtful, and probably want regulation of these technologies. So,
I mean, what do you call Cambridge Analytica? I think that's one of the first shining moments where you saw data science being weaponized for a purpose, right?
Yeah, some people might disagree with that. They gave a link in the question for like kind of a military application. So really good questions from the audience. That was fun. So thank you so much.
Yes, thank you, Ben and Patrick, for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us. The presentation slides and the recording will be made available on our BrightTalk channel in a few hours. And have a great rest of your day.
Thanks so much.